Hello everyone, I'm here to talk to you about architecting software for leverage. And to start, I'll just define quickly what I mean by leverage here. Here is a Google definition, but what I mean is leverage is the amount of value you can get relative to the depth of the investment you made. So you expect to get a higher value than the amount of investment that you did. And in the software context is the amount of the decisions you take, the choices that you made, or the technical debt that you acquired relative to the amount of value that you could create. I want you to take away from this talk is to taking a look at some examples of architectural decisions that we took throughout the Nubank's trajectory that were aimed at taking the highest possible leverage at the time. You may be in a similar position in your company in a future company and in a phase that you will be taking those decisions, and you can take us as an example or at least have a mindset. And to give you a little bit of context, I'm Lucas Cavalcanti. I'm a principal software engineer at Nubank since end of 2013, so a little bit over 7 years now. And I'm based in São Paulo, Brazil. Nubank, for those who don't know, is the leading fintech in Latin America and was ranked the biggest digital bank in the world. And at Times Magazine, we got one of the 100 most influential companies in the world as well. We were featured on the Times Magazine as well. So a pretty big achievement from a company that has a little bit over 7 years. This is an example of our growth curve. Here is an actual number of customers here plotted in this graph but we got to 35 million customers now. And we process billions of Kafka messages every day, of HTTP requests every day, in a system that has hundreds of microservices and designed by hundreds of engineers. And it's a pretty big scale, which was not always at this size. So I walk you through this presentation some phases of the company. The first one, which was the startup time, when we were value time to market and feedback. Going to the growth time, when we changed the focus to really resilience and adaptability. Going next to the consolidation time, when the most important aspects were reliability and observability. Going last to expansion time, when we value flexibility and extensibility. These were the values that were important to us at those phases. And starting now, the startup time, which is this magical time where anything is possible, including failing and not having a company. In our case, this happened on late 2013 to early 2015. We had that incredible change, that magical time when you had a greenfield project and you get to choose any technology that you like to, and you have to have a good reason to do that. And a small office, which was actually a little house in São Paulo, in a friendly neighborhood in São Paulo, when we launched the first product, which was a digital-first credit card with no fees and real-time experience on the app, which was unheard of at the time. We were the first ones to do that in Brazil, at least. Too many unknowns. We don't know what directions the company will take or if it's going to succeed or not. Limited resource, just a dozen people running the whole company, and we need to make that work. And in our case, we had a license deadline. If we were not operating by May 2014, we will have to apply for a license that will take up to 2 years to be granted, which would be basically death for the company. So the first lever that we need to do is the technology choices. And the value here is time to market. We need to launch as fast as we could. And the leverage type here is maximizing the amount of work you don't have to do. And don't create a thing that's more complex that you need to do at that stage. So we chose as a database the Atomic, which is a very niche database, which is an immutable ledger of facts. So you get auditing for free. Every update preserves history, so you don't lose previous values. And you can query database at any point in time. So this is very helpful for both auditing and debugging later on. We chose Clojure, which is a functional programming language that runs on JVM. So we can leverage the whole Java ecosystem. Everything that's written in Java we could use in Clojure. We get immutability by default, and pretty much every decision that the language took led us to simplicity. So simple made easy, which is a good talk by Rich Hickey if you want to take a look. This is true, we use that in production. We have functional programming that's close to finance. That's why we chose Clojure as well. It's easier to map finance logic in a functional programming language. And we chose to use the hexagonal architecture so we can have a default way, an organized way to see our code. We chose also as messaging technology Kafka, which was booming at the time, which has a persistence log of messages with a TTL, right? Like it's not forever, but during a period of time, you can inspect and look at all the messages that were produced. And we have the ability to reset offset, so you can reprocess old messages if necessary. And we had to do it a few times at the beginning. And we get partitioning by default as well. So scaling Kafka was also a little bit easier at the moment. The depth that we had at that point is that we chose some of the technologies that were very niche and somewhat unconsolidated. They were not established yet. So it was very hard to find people that had some experience on those languages. So we had basically to not ask for that, to teach people that in the beginning of the company. Next levers is vendors. When you're looking at time to market, several times buying instead of building is the best choice. So the first one is using the cloud. You don't want to be managing your own machines at this phase of the company. So we used AWS with CloudFormation for deploy automation. The very beginning, from the very beginning, we used DynamoDB for as a backend database for Datomic, which was also easy to operate. And we chose to buy an off-the-shelf credit card solution. So we didn't start building the whole credit card system. We started using a company that already processed credit card transactions. So we could leverage, instead of building, we just integrate with that company and we can create the first product faster. And the depth here is that now by using those vendors, we are limited by their ability to grow and to scale and to respond to our problems, which is not always ideal. The final one here on the startup time is practice. And this time the value is getting fast and early feedback. And to get that, we need to build a good foundation on top, so we can build on top of it faster over time. And the thing here is that building the foundation takes time, which is not always available when you're in startup mode, when you want to launch as fast as you can. And by luck, we could do that. We had some time. So we took the chance to build a good CI/CD environment as well. So continuous deployment was very important for us at the time. So we set up some practice to do continuous deployment. We had a very rudimentary fault tolerance, but still present. We, from the very beginning, had immutable infrastructure. So every time we deployed, we created new instance on EC2 and destroyed the old ones. So you don't have the complexity of dealing with infrastructure changes. And we chose from the very beginning to use microservices because we knew that the financial domain is very complex. So containing that complexity in smaller pieces, in this case, a smaller service, was very important to us at the time. So we already started with that. And moving a little bit further, if we are lucky and we are successful, the company goes to a growth phase, which in our case was between 2015 and 2016, when we experienced a way faster growth than expected. We were expecting to get to 1 million customers by 5 years, and we got to that in something like 18 months. So we needed to respond to that. And at first, the office didn't scale, and we had to move to a bigger place. The vendor was not scaling. The credit card processor was not scaling. So we needed to keep the system working, even though the vendor was not scaling. And the technology, the decisions we took at the very beginning were starting to not scale as well. So we started to see the first bottlenecks, which would be very, very, very hard to fix in this hyper growth scenario. So the first lever here on the growth time is practice. With the value we scale for valuing for scalability or fault tolerance, we can and we should, as much as we can, avoid optimization or at least delay optimizations, because optimization code or optimized code is way more complex than regular code. And in a complex domain, this is get off the track very rapidly. So to do that, we used infrastructure sharding. Instead of sharding just the database or just a piece of the infrastructure, we had several copies of the whole Nubank system, which was each shard was a copy of the whole infrastructure, which were scalability units. So we could have a limited number of customers running on that copy and go to the next copy when we reach the new set of customers, and keep creating copies as the base grows. Right? And if the shards are small enough, you don't have to optimize code, or you can delay it as much as you can. To do that, we had to improve our CI/CD. We needed frequent and automatic deploys. But the end-to-end tests that we set up at the very beginning started to not scale as well. So they started to take more than 1 hour to run. And we had to replace them with consumer-driven contract tests, which will run way faster with a little bit less guarantees, but still better to keep deploying frequently than waiting too much to deploy. And we started migrating to Docker instead of using EC2. The investment here is that the project to run sharding was more than 1 year long, which was a very big project for that time in the company. And we had to design like new tools to accommodate for that. And the depth here is that the project took way longer than expected, and the customer base grew way faster than expected. So we end up with the first shard being way bigger than the other shards. So for a very long time, this shard was a special shard that was basically the canary for any performance problem that we could get in the system, was this first shard. And also, each shard has a minimum cost, no matter how much customers how many customers you have in it. So the cost here, like we started to spend a lot of money also running each copy of the shards. The next one was in-housing. The next lever is in-housing, especially because our vendors were not scaling. So we started to own our own destiny on the most important aspect of the business. So we started processing credit cards in-house, bringing feature by feature of the credit card in-house, so we could control our own scaling. The same thing for customer support. Delighting our customers was the biggest differentiator that we had at the company. So we also brought the customer support tools in-house and the customer support people in-house as well. So we also had to design for that. The big investment here is that bringing those features of the credit card took more than 18 months. And every little feature was a migration that we had to do. So it was a huge investment that paid off hugely. The vendor would not scale to 35 million customers, and we could. And the depth here is that because of that bringing in-house several features, we took a long time without having any major product changes. So that was a little bit bad. And if we're lucky enough, we go to the next phase, which is the consolidation time, which for us, when we reach a cruise mode, in the company, which for us is between 2017 and 2018, when we were scalable, but not in a stable way. Sharding helped a lot with the scaling, but we reached a scale where every little corner cases that affected 0.1% of the customers were happening to hundreds of customers, to thousands of customers. So we had to have a way more stable product or system than we were expecting to need to have. The office also didn't scale, so we need to move to a way bigger office that would accommodate 1,000 people near Avenida Paulista, which is one of the most famous streets in São Paulo. We launched our second product, which was the checking account by this time. And on this phase, we were already generating huge amounts of data, so we started to have to analyze that data. So this was also a very important point for us. The first leverage here on the technology side, we were aiming for scalability and adaptability. And the leverage here is at that scale, we need to be able to do infrastructure changes more easily. So we migrated to Kubernetes, which was also booming at the time. And it comes with an ecosystem of several infrastructure tools. And with the number of services that we were getting, it was scaling way better than AWS CloudFormation. We also started to set up better monitoring tools. So collecting real-time metrics with Prometheus plus Grafana. And these metrics were also being used by other tools like Opsgenie, Slack, our CI/CD for canary deploys. So these were it was very important for us to scale. The investment here was another year-long project that we had to set up Kubernetes and also migrate shard by shard to Kubernetes, while the system is already running for millions of customers. So it was a pretty complex operations that we were able to pull it off. And the depth here is that while we didn't fully migrate, we started hitting AWS limits for creating resources or for number of resources and spending a lot of money on duplicated infrastructure until the project is finished. It was a very big deal here. We also had to invest a lot in internal tools for resilience and observability. We needed to make it easy for the engineers to operate on the system, especially with the number of services and the number of people. So we created a common light repository that we call NuCLI, with the most common operations like restarting a service or sending HTTP requests to a service with our credentials that were one command away to be run. And also a tool for declarative infra, a repository when you can describe the resources you can get on your services, and it got applied automatically by the tool. Right? And the investment here is we needed a dedicated team to create, maintain, and ensure that all these changes were applied. And at that point, when we are consolidating, data becomes very important. The amount of data we have is not processable by regular tools. And you need data to do pretty much every decision on your company. So we used Scala plus Spark to process all the data, extracting the database, the data from all the services database across all the shards. We have an ETL process that is a repository of datasets, the definitions that pretty much everyone in the company or pretty much every place in the company contributes to, which outputs everything into a data warehouse so everyone can access later, which is integrated with some BI tools and we can use for support our machine learning models. And we can use that as a consistency tool as well. So with that amount of data and using a distributed architecture, failed distributed transactions become a very big deal. So we use also the ETL to check against the consistency against the systems as well. Investment, again, it was another big project to create the initial ETL versions and start iterating on it. And we also have a dedicated team to make sure that this works well. And finally, we get to the expansion time when we are where we are now. And at this time, which was from 2019 to now, we started to have products for everyone. That's why you see this inflection point on the curve. We stopped saying no to customers that were asking for credit cards, for example, and we started offering products for everyone. And we started launching in many countries, in many offices, and many other products that we were building. And we started acquiring companies, so also the interface between companies became important. So the first lever here on the expansion time is for extensibility and productivity that I'm calling here horizontal platforms. There's basically technology specialized teams that build abstracted tools for every other team to use. So for example, mobile and web, we have a team building tools in Flutter and design systems, component libraries. So the regular engineer, the engineer that's not a specialist, can still evolve and use that system. Same for infrastructure. Instead of everyone knowing how to operate Kubernetes, we create abstract tools so every engineer can do that. We also built an experimentation platform because at this size, you want to run experiments, you want to improve your products. So having a platform that allows for you to do that easily while monitoring KPIs and whatever is relevant for the test is very key. And again, we need now dedicated teams to create, maintain, and operate those platforms to make sure that every engineer can be productive on any technology we use. And finally here, business platforms, which is for domain specialist teams to building abstracted APIs for all the other product teams to use. And here is the point that we can get to innovations, to endless possibilities of every possible platform product that can build. Examples of it is, for example, banking as a service. So creating platforms to run the basic operations of a bank. For example, the credit platforms. So you don't have to figure out how to issue a loan or how to report it, how to account for it. We have a platform where every product can issue a loan. And as soon as that's done, the product can do whatever it wants to do. The same for future, for assets and payments platforms and open banking. Okay, so these are building blocks that we can use for building a bank. We also, on the credit card side, we had to launch credit card in other countries. So we had to make the system more generic. And to do that, we broke the system into the most relevant parts of credit card. In this case, for example, handling limits, credit limits, or closing bills every month, or processing credit card transactions in different ways. If the customer doesn't pay us the full bill, also generating the debts and renegotiating the customer debts. Also, when you get to many products, having a flexible acquisition process is also very, very important. So we use that. And the investment here is that for the domain platforms, we need to have a very deep understanding of the domain to do that. So we went through a long period of discussions to design what is the right break in the system on the platform side, because creating the wrong abstraction here leads you to failure as well. Like you have to be sure that you're creating the right abstraction, because the cost to rebuild an abstraction is very high. So that's it. Recapping, we were on the startup time trying to delay writing code as much as we could while building the foundation for growing. And when we get to grow, we started bringing in-house all the core features that we needed to, and we started doing sharding so we could scale faster. The consolidation time was all about maturing our infrastructure and creating a data environment so everyone could use data to make the company grow. And finally, the expansion time, it was about building horizontal and business platforms so the possibilities would be multiplied and the productivity of everyone would be multiplied. So that's it. Thank you very much. I hope you enjoyed this talk. And last talk, the Q&A.
Thank you very much, Lucas, for what a amazing talk, a comprehensive view of this story, a beautiful story of Nubank, and bringing all these insights connecting to company phases to the architecture trade-offs was like great. Thank you very much for that.
Thank you. Thank you. And thank you all for watching me so far. Here.
Yeah, it was amazing, and we saw the chat, lots of questions. So I try to group all those and try to tackle that as much as I can. Keep an eye on the chat. Keep an eye on you. You're going to be a challenge for me here as well. So the first thing that I want to ask you, it's another question that came up in the chat is. You started with the idea to use microservices. What usually when people pick the microservice architecture is more Connor's law justification. When you were small and you didn't have, but you switched that. Did you consider go for monolith? How it was the thought process about that?
Yeah, I think like the main reason was because of the complexity. The domain complexity that finance, like we knew that the finance domain was very complex. So we had some concerns on the system already at that time that were very different, like handling credit card transactions versus handling customer data versus handling the acquisition process. So we started with very few services. I think it was like 4 or 5 just. But already broken into services because we knew that if we were going to succeed and scale, we would have to need to go to that architecture eventually.
Yeah, makes total sense, but this is still a challenge, right? Because it's more distributed systems, way more complex than a single monolith. And that goes towards the some questions also in the chat about the sharding. And when you start scaling, you mentioned the sharding. And one also mentioned that you have somehow balancing sharding and the challenges to create sharding. And using the question that I had in chat, did you have to deal with outliers on this, require a larger amount of resources in this sharding?
Yeah, I think we do have like some people that run like 10x transactions or 100x transactions more than the other ones, but it eventually just affects that particular customer. Like their bill may not open in a good time because there are too many transactions there, but it doesn't affect the other ones because most of our operations are in batch already, so it doesn't affect us that much for that. But we did have that problem on the first shard because we took longer than expected to build the sharding infrastructure. So the first shard got too long with people that had the customers that were too old. So it's the customers that have the longest time at Nubank and the highest amount of customers. So that created some challenges for us. And it still does sometimes, but now all the shards have about the same size, and we are managing them better.
Yeah, and then goes like connect to sharding. How it was the migration to Kubernetes? Some questions around the Kubernetes move is, did you adopted a service Kubernetes offering like EKS or something like that, or you went to Kubernetes, and how was this transition from your infrastructure that you already mentioned that it was immutable, but how was this transition?
Yeah, I think like the main thing to take into account here is that this was 7-8 years ago from now. So Kubernetes was just launched in like 2014 or 15 or something like that. It became publicly available. So we didn't have those tools when we started the company. We didn't even have Docker when we started the company. So we had to migrate to Docker and then migrate to Kubernetes. and then eventually migrate to EKS, because EKS also didn't exist at the time, and it started existing in São Paulo region, I think this year or something like that. So I think like if we were starting the company today, we'll probably use EKS on Amazon, and that's it. But we didn't have those tools at the time.
Yeah. Another question that I'm seeing quite frequently here is the use of Clojure and the stack that you mentioned. That's not that common, I'd say, but you take advantage of the ecosystem that you also mentioned in the talk, the JVM. Can you help us understand a little bit this? Sometimes sounds like a dichotomy, like you're starting easy, but you pick something that very few ones are picking to start with.
Yeah, the main thing for us on Clojure is that the language pushes you into simplicity from the very beginning, in a sense that the amount of the language you have to learn to be successful at it is very small. It's like you can be productive in Clojure by studying for a couple of weeks, maybe, and all of our services look about the same. So it's easier to, like, as soon as you get rid of those parentheses, like you can switch from braces to parentheses and be fine with it. Everything else is simpler. Like we don't have like that cognitive load that most languages have to learn syntax and the constructions of the language, everything. Like Clojure is Lisp is parentheses and symbols. Like you don't have to learn that many language features to be able to use it, or to copy paste the other code, right? Like that we all do.
One question now regarding more business aspects is, how did you cost factor into your architecture decisions? And like you plug in the same question that you answered in the chat, when you're operating finance, you need to you follow a lot of regulations, right? How you deal with this distinction, infrastructure, business code, and now the challenges of regulations?
Yeah, we do have specific teams. Like when we reach a certain size, it pays off to have a focus team on these specific aspects. So we have a team just managing risk and like operational risk, or a team just doing platforms for the regulated part of the company. Like giving a loan is very regulated in the market, at least in Brazil. So we created a platform around it. So every time we need to build a loan, the platform handles it, and we have many teams that can issue loans easily. I think like that was mostly the way we handle it, is by having this specialized team that know a lot about the regulations, by how to assess risk, and then periodic assessments from other teams that might be impacted by it.
In quickly question, so you mentioned a few times the specialized teams and specialists. What are the team size that look like in Nubank?
The team is not just engineers usually. Like we have teams with BAs, with product managers, with business analysts, product managers, sometimes data scientists. But for the engineering part, we usually have a tech manager and 2 to 6 engineers per team. Mm-hmm. It varies a lot on the context, right? But it is around that side per team.
Okay, gotcha. The 2 pizza rule. Okay, now switch a little bit the gears to data. And we have less than 5 minutes, so I'll try to tackle a little bit more. You mentioned ETL. What tools you use for ETL?
Well, we use Spark for building all the infrastructure to transform the data. And we had to build a lot of tools internally to extract datomic data and transform it in a way that's consumable by the ETL. Mm-hmm. I'm not I'm not specialist into the data part, so I don't know very much about the specifics. But we use, I know we use Mesos clusters to run the clusters that will run the ETL process. We use some BI tools like Databricks, like Looker, like I think like we have several tools that this whole ecosystem uses, but it's basically we have our own repository of dataset the definitions that the whole company contributes, and it's Spark, it's Scala with Spark with some abstractions that we created, so it'll be easier for people to use.
And I will ask the last question that I have and connect to the last session that we have today. You started with Kafka, and today lots of things are about streaming, but you picked like the batch processing ETL route. Any reason to not go full heads-on streaming? It wasn't that popular in that time, and you need to adjust. And just a heads up, this is a topic of the last session that we have is from batch to streaming.
Yeah, the main reason was that when we needed ETL, Kafka Streams was not stable or released at the time. So we went and we already have data on Datomic from like hundreds of microservices or dozens of microservices at the time. So it'll be hard for us to migrate to a Kafka Streams mode on the architecture we chose by then. If we were to start today, like we would go to stream. We do have some use cases where streams were more appropriate. So we use it in like real-time collecting metrics, for example. We do use Kafka Streams, but for regular database part, we don't.
Thank you very much, Lucas. We are running out of time, unfortunately, but we are back in the panel, so we will continue this conversation on that now on the Hangouts, and that we have a lot of still unanswered questions. Thank you again.
Thank you all for watching so far. I'll meet you in the Hangouts room now if you want to.